Please mute your mic. Just law pressure, the sum of the partial pressure of all gases. Now there is no disturbance, right? No, sir.
Yes.
No, sir.
Copy it fast. Total pressure will be equals to PA plus PB plus PC and so on. Where PA is equals to mole fraction of A into PT. Okay. Any doubt till here? Any doubt till here? What will be the ratio of the partial pressure of two gases? Ratio of partial pressure of two gases in container is PA by PB will be equals to XA into PT divided by XB into PT. That will be equals to XA by XB. XA will be moles upon total moles divided by moles upon total moles. This will get cancelled out, will be equals to moles upon moles. Any doubt till here? Any doubt till here? Any doubt till here? Any problem till here?
No, sir.
No, sir.
क्वेश्चन ट्राई कर Let's try one question. Let's zoom out. Zoom out. What do you want to see? Done. Make it equal mole first. if equal mole of hydrogen and oxygen are present in container container, if equal mole of hydrogen and oxygen are present in the container, then ratio of the partial pressure exerted by them will be
Sir, one.
very good. PA by PB equals to NA by NB, given NA equal to NB. So PA by PB will be equals to 1. So answer will be 1 is to 1. Very simple. ठीक, इसको हम थोड़ा सा चेंज करते हैं. If equal mass of helium and SO2 are present in the container, then ratio of partial pressure of helium and SO2 will be इक्वल मास दिया है तो क्या करेंगे. Let mass of both be yes is x by 4 divided by x by 64. It will come out to be 16 by 1, that is 16 is to 1. That will be the answer. Understood? Any problem to anyone in this?
So could you please show the previous part before this? Yes, sir, thank you.
Done, all of you?
Sir, slowly.
Can we try one more? All of it until here? is equal weight of hydrogen, helium, and methane are present in container and total pressure is 13 atmosphere, then partial pressure of hydrogen will be partial pressure of hydrogen will be if equal weight of hydrogen, helium, methane are present in container and total pressure is 13 atmosphere, then partial pressure of hydrogen will be yes. Okay. These two questions we have done.
So about that,
Nothing.
yeah,
Yeah,
okay,
this
done,
was
sir.
also
Thank
there.
you, sir.
Take this red
Yeah,
one also.
yeah, okay. Taken, sir. Thank you, sir.
Yes, let's try this question. Anyone got it? Lisa, Joseph, Davis, Struha. Anyone did this one? Sanjana. Let the mass. क्या चाहिए मैं पार्शियल प्रेशर चाहिए ना what is the partial pressure of hydrogen it is x of hydrogen into total pressure is given to us so we just want x of h2 for x of h2 we should know the total moles for that let the mass of all the gases is 16 gram each. So intentionally I'm taking the 16 gram mass because this is the mass of this methane. If you take 16, your numerical or your calculations will become easy. You can easily calculate the moles for each case. Moles of methane will be 16 by 16.
Sir,
Moles, yes.
sir, there is some disturbance, some weird noise is coming.
Is it?
Yes, sir.
Now it's clear.
Yes. Thank you.
So I took the mass 16 gram for each. Then I calculate the moles for each case because I wanted the mole fraction. 1 mole, 4 mole, and 8 mole. So total mole becomes and T becomes 13. And mole of hydrogen we know is how much? 8. Understood? So now we can put in the main formula. Partial pressure of hydrogen is 8 by 13 into 13, 8 atmosphere. Very good, Rishikesh. Shruti. And
Can you explain this question again? I again got disconnected.
it was given that equal weight of hydrogen, helium, and methane are given. And the total pressure was given as 13 atmosphere. We wanted the partial pressure of hydrogen gas. We know that partial pressure of hydrogen gas is given by the formula mole fraction of hydrogen gas into total pressure. Total pressure we already know, which is given in the question as 13 atmosphere. So we just want moles and total moles. To calculate moles and total moles, we kept the mass of all gases as 16 gram.
So
By
why you get
keeping
16
that,
gram only?
because that makes my calculation easy. You can take its x gram also.
Okay, sir.
But 16 gram I took because it is the mass of the heaviest gas and it makes my calculation easy.
Okay, sir.
16 by 16 is 1, 16 by 4 is 4, 16 by 2 is 8. So I got the total moles, that is 13 mole. I know the moles of hydrogen as well. Now I can put mole upon total mole into 13. That will be my answer.
Okay, okay, got it, sir. Thank you, sir.
All of you understood this now? All of you understood this now? Try one similar question of your own. Try one similar question of your own. All of you done this one?
Yes, sir.
Yes, sir.
All of you. Can we move to the next question?
Yes, sir.
A gaseous mixture contains neon and O2, each having mass 80. Total pressure of mixture is 26 bar. The partial pressure of neon and oxygen will be,
Sir,
yes,
sir, I lost my connection for the past 5 minutes. What should I do?
just take the screenshot of the last question.
Can you scroll down a little?
Down.
Yes, sir.
Done.
Yes, sir. Thank you.
Please try this question fast. It is exactly same as that of the previous one. Sixteen and 10. What about others? We know partial pressure of neon will be mole fraction of neon into total pressure. Partial pressure of oxygen will be mole fraction of oxygen into total pressure. Moles. Calculate the moles will be given mass upon molar mass. Moles of oxygen will be given mass upon molar mass. So this is 4, this is 5. We got total moles. We got total moles. Now put it in the main formula. Oxygen was 3.2, 32. It will be 5 by 2. Okay. Any doubt till here? So pressure of neon will be mole fraction of neon this will be total moles into 26. That will be mole upon total mole into 26. So it will be 16. 16 divided by total moles into 26. That will be 5 by 2 divided by 13 by 2 into 26. 10 bar. Very good, Varun, Shifa, Rishikesh. Sanika didn't do this one.
Excuse
Mangesh,
me, sir.
Sanjana. Yes,
So you got 13 by 2.
it was the sum of these two. Total mole is 4 plus 5 by 2. LCM लेंगे. It will be 8 plus 5 by 2. That is 13 by 2. Right? Janet.
So can you explain this again?
See, it was a gaseous mixture contains neon and oxygen. Okay, each having mass 80 gram. If the total pressure of the mixture is 26 bar, the partial pressure of neon and oxygen will be will be into total pressure. Transfer pressure of, please mute your mic. Transfer pressure of oxygen will be mole fraction of oxygen into total pressure. Total pressure is given in the question, that is 26. We just have to calculate the mole fraction. For calculating mole fraction, we want moles first. So first we'll calculate moles, given mass upon molar mass. We'll calculate the total moles. Then we'll put in the main formula. We'll get the answer.
Okay, sir, got it. Thank you.
Yeah.
Excuse me, sir.
Yes.
So that the moles of oxygen and the total moles that total the alternative formula of it is of XO2, right?
Yes. The mole fraction is XO2.
Okay, sir.
Understood, all of you? Understood, all of you? Okay. So let's try other type of questions. Like two gram of gas A introduced in a vessel in a evacuated flask at 25 degrees centigrade. Pressure of the gas is 1 atmosphere. Now 3 gram of another gas B is introduced in the same flask. Total pressure becomes 1.5 atmosphere. Ratio of molecular masses of A and B will be ratio of the molecular masses of A and B will be you have done KTG in physics? You have done KTG in physics? No.
No, sir.
Okay. Done. Now the pressure of gas A is given as 1 atmosphere and pressure of Pa plus Pb is 1.5 atmosphere. That means the pressure of B is 0.5 atmosphere, right? We want the ratio of molecular masses. We want the ratio of molecular masses. We know that the ratio of partial pressures is equals to the ratio of moles is equal to the ratio of moles. Now, what is mole? Given mass upon molar mass divided by given mass upon molar mass. We are given with the given masses 2 by Ma, 3 by Mb. That will be equals to 1 upon zero point 0.5 is equals to 3 into out. So 3 by 1 is Mb by Ma and Ma by Mb will be 1 is to 3 a mode.
Excuse me, sir.
Understood? Yes.
So how you got that 1 upon zero point 0.5 from where?
1 upon zero point 0.5. I know the pressure, partial pressure of A is 1 atmosphere and partial pressure of B is zero point 0.5 atmosphere. I just kept the
Oh,
values.
okay, sir.
Understood, all of you? Very good, Shifa. Amod, Lisa, Madhura is not there. Malakai, Akarsh, Aditya, Arya, Ibial, he didn't give answer. Hiram, Johan,
I gave.
Natasha, Pranil, Sanjana. You gave it? I was asking Ibial. Tanmay, very good. Can we move to next question now? Very good, Raghavi. What is the total pressure? Total pressure was given as 1.5 atmosphere. Yes, it was given in the question, na? Total pressure becomes 1.5 atmosphere. You didn't read the question? Sir, my keypad numbers are not working, so I can't give the answer. Okay, कोई बात नहीं गौरव. A and B are present in container with pressures with pressure of 200 and 180 of Hg. When the third gas added to the container total pressure becomes 1 atmosphere. Calculate the mole fraction of gas C. Done? आकर्ष हो गया. राघवी, शानवी, डन. लीजा, जोसेफ, हंसना उतना बंद कर दो यार, तुम क्वेश्चन पे ध्यान दो ना. कितना क्या सॉल्व कर रहे हो यार. पी ए प्लस पी बी प्लस पी सी is 1 atmosphere. Very good. What kind of mole fraction is this? मधुरा आपसे रेशियो नहीं पूछा है, मोल फ्रैक्शन पूछा है. You should say 1/2. Yes, Sakshi. We know 1 atmosphere is 760 mmHg. अभी तक कोई भी नहीं बता रहा था, अभी एकदम सबने बता दिया है. Screen is not visible. Someone please send the screenshot for her, for him as well. This is 180 plus 200 plus. Very good, yes. PC equals to 760. So PC will come out to be 380. PC will come out to be 380. We know PC is mole fraction of C into total pressure. So 380 is equals to XC into total pressure. ये आ जाएगा 2, ये आ जाएगा 1. So XC will be equals to 0.5.
Excuse me, sir.
हाँ जी. Yes.
Sir, that 760 is the total pressure, no?
Yes, it was total pressure, which was given in the form of 1 atm.
Okay, sir.
Yeah. Akash, I asked you in the first, and you're almost at the last. Done, all of you? Limitation. Sanika, can you see the screen now?
So scroll up.
Rishikesh,
Yes.
are you there in the meeting? Okay. Done.
Done, sir.
Gases should not react with each other. Should not dissociate or associate with others. They should remain independent gases. We want independent gases. Dalton's law does not work for N2H2 as they can react, H2O2 as they can react, SO2Cl2 as they can react. Understood? So remember this much at least. It won't work with them. Written, all of you? Written, all of you? कुछ और पढ़ते हैं फिर. Write down Graham's law of diffusion. Please mute your mic. Graham's law of diffusion. What do you mean by Graham's law of diffusion? What do you mean by diffusion? What do you mean by diffusion? Diffusion का मतलब mixing of gases. Intermixing of gases, or the movement of gas from high pressure region to low pressure region. High pressure region to low pressure region. But we are reading Graham's law of diffusion. We are reading a particular law. What does it say? Graham's law states that rate of diffusion of any gas is inversely proportional to the square root of masses. Square root of masses. Mass किसका? Gas. So rate of diffusion of a gas is inversely proportional to the square root of its mass. Stop it fast.
Done, sir.
What do you mean by rate of diffusion? Can we say it's speed? The rate
Can you scroll up?
Sir, can you scroll up a bit?
of diffusion of gas A is inversely proportional to the square root of mass A.
Mass of A.
Yes, molecular mass of gas A.
Okay.
Understood? Now, rate of diffusion can be rate of diffusion can be distance traveled distance traveled by gas per unit time. Distance traveled by gas per unit time, that is d1 by t1 divided by d2 by t2 is equals to square root of m2 by m1. It can be this. It can be this. It can be volume of gas diffused per unit time. Volume of gas diffused per unit time, that is V1 by in. So depending on the question is given in which form?
So just scroll up. Done, sir. Thank you, sir.
Understood. Question can come in any form. It can be rate of gas A. Rate of gas A divided by rate of gas B. Rate of gas B equals to square root of MB by MA. It can be this. So it can be anything depending upon the question in which way it is asked. Done. Done. Any doubt to anyone in this? Very simple. well हम इसे सिंपल क्वेश्चंस करते हैं. Which among the following gas
So can you please scroll up?
which among the following gas will have maximum rate of diffusion? Helium, hydrogen, methane, or SO2? Done? Very good. All of you done this? Very good. The one which has minimum mass will have maximum rate of diffusion. Easy question. Understood? एक और क्वेश्चन करते हैं with a different language of similar type. Four gas balloons A, B, C, D of equal volume containing hydrogen monoxide and CO2 respectively were pricked were pricked with needle were pricked with needle and immersed in the tank of CO2. Which one will shrink after some time? Which one will shrink after some time? A, A, A and C, B and D, A and B. थोड़ा समझ के करो इसको. Based on the similar principle, just the language is different. So we have a tank of CO2. We have a tank of CO2. We have a tank of CO2 and we have four balloons. One has CO2. CO2 है? Yes, one has CO2, one has CO, N2O and H2. ये है A, B, C, D. Now, when they are pricked, इसमें अगर आप छेद कर दोगे, so these gases will try to go out. Very good, Amod. These gases will try to go out. H2 will try to go out. N2 will try to go out. CO will try to go in. अगर बाहर निकलने का रेट ज्यादा है, if you have more rate for coming outside, then they will shrink. If there is less rate for coming inside, then they will expand. Understood? Rate of
So just explain.
coming, just wait, coming out from balloon is H2 CO N2O equals to CO2. I said we had a tank in which four balloons were kept. Okay,
Yes, sir.
and they were kept in the tank of CO2. Now, when you made a hole in that, CO2 will try to go in, and the gases which are present inside, they will try to go out. Yes or no?
Yes, sir.
Now, hydrogen has smaller mass, so it will move faster.
Yes, sir.
So it will move outside faster than the CO2 go inside.
Yes, sir.
So basically, your hydrogen will come out more,
Yes, sir.
so it will get shrink.
Okay, sir.
Now your mass of N2O is same as that of CO2. Mass of N2O is same as that of CO2.
Yes, sir.
So what will happen? They will move with the equal rate,
Right, sir.
so it won't shrink. Slightly a conceptual question, but based on the previous problem only. Understood?
Yes, sir. Thank you, sir.
Can I give you one more question like this? एक और
Yes,
क्वेश्चन
sir.
ऐसा करते हैं थोड़ा, है ना?
Excuse me, sir.
यस सानिया बोलो.
The rate of gas coming out is the rate of shrinking.
Yes, because if it is coming out, your balloon will shrink only. You know what is shrinking means, right? Saniya,
For gases, I don't know clearly.
अगर कोई चीज गैस बलून के अंदर जा रही है तो इट विल एक्सपैंड, और आप उसमें से बाहर निकाल रहे हो तो इट विल श्रिंक. सानिया,
Okay, sir. Okay, sir.
है
I
ना?
just
मान लेते हैं
put the wrong
ये
feeling.
बलून है.
So scroll up.
Just wait a second. So if it is coming inside, then it will expand, and if
Yes,
it is
sir.
coming out, तो वो shrink हो जाएगा.
It is the size of
Yes.
the balloon.
Yeah, it's the size of the balloon. That is why I'm giving you one more question like that, so that things will become more clear. Please do it fast. Done.
Yes, sir.
A balloon filled with CO is pricked and thrown into a tank of nitrogen gas under same temperature and pressure. The balloon will the balloon will shrink, enlarged two times, enlarge four times, remains same. ये वाला करो. Remains same. Very good, Spruha. Janil, Joseph, Rishikesh, Akash. Sania did reply. Mass of CO is 28. Mass of N2 is 28. So rate of going inside and coming outside will be same. So it will be remain same. All of you understood this? Then let's move to the numericals. Can we move to the numericals now? All of you understood these theoretical questions? एक और all of it done till the end. सबका हो गया यहाँ तक. So it will mean that there will be equal volume of N2 and CO in the balloon. There will be the equal rate of inside and outside, you can say. At any instant, it will remain same. Yes, Kamar. At any instant, it will remain same. Yeah. तो एक और ट्राई क्वेश्चन करते हैं. If we have a long tube of 12 meters, for example, from one side we are throwing ammonia gas, from other side we are throwing HCl gas, then this is towards HCl, this is towards ammonia, and this is at the center. White fumes, white fumes of HCl, sorry, of NH4Cl will be produced at A, at C, at B cannot be determined. इसको मैं बदल देता हूँ so that it won't create confusion. इसको हम B बोल देते हैं, इसको C बोल देते हैं. Done. Lisa, Jeremiah, Shanvi, Raghavi, Joseph, done. Janil, Akarsh, Mangesh, Yash, at और कोई at A. Very good, Madhura. At A. Sanjana, can you give me reason for that? Why it's at A? I think it should be at B. Sanjana, can you speak up?
Excuse me, sir.
Yes.
As the mass of NH3 is less, so it will go more fast and will get combined with HCl at
Mhm.
point E.
Very good. That's what I was asking. So NH3 mass is less, it will move faster, faster तो वो यहाँ मिल जाएंगे. Very good. Very good, Sanjana. Understood? Yes. तो यार अगर आपको ये पता है तो आपने बी क्यों आंसर किया था? सी सी कैसे? यस का मत आपने बी और सी दोनों आंसर कर दिए हैं, ए बचा है बस.
So we are assuming that C is in the middle of the tube.
Yes, we are assuming that
Okay, sir.
because we do not know actually where it is present. We can calculate that as well, but I'll tell you in the numerical types. As of now, we are assuming this in the middle, और इसको हम मान रहे हैं towards NH3, and this is towards HCl. Understood?
Yes,
Now,
sir.
can I give you one numerical? एक numerical करते हैं बढ़िया सा.
Sir,
Yes,
sir, can you please explain this question once again? I just got disconnected.
I said that we had a tube which had two open ends. From one side, we have pushed the or thrown ammonia gas. From the other side, we thrown HCl gas. We know when NH3 reacts with ammonia, NH3 reacts with HCl, it will give NH4Cl, which have white fumes. We just wanted to know at which point, whether A or B or at the center of the tube, that white fumes will be formed. So what we said, as this has less mass and this has more mass, so it will move more, it will move less. So NH3 will come towards HCl and HCl will move less. So towards A, your white fumes will be.
Yes,
NH3
sir.
has less mass, so it will move more. HCl has more mass, so it will move less. Hydrogen diffuses 6 times faster than the hydrocarbon predict the hydrocarbon.
So could you please scroll down?
Try this. Done. So, ए ए कैसे आया ए मधुरा? साक्षी तो पेंटेन बोल रही है। मधुरा, can you defend that A? Sanjana, Padma, Sanika, are you there? You can see the screen. Yes, Kamat. Rate of hydrogen and rate of that hydrocarbon will be inversely proportional to mass of hydrogen and mass of that hydrocarbon. Rate of hydrogen is six times the rate of rate of hydrogen is six times the rate of hydrocarbon is equals to mass of hydrocarbon divided by 2. So 6 times means 1 by 6 root 2. कैसे? Taking square both sides. 36 is equals to m of hydrocarbon divided by 2. So m of hydrocarbon is 72. Mass of hydrocarbon 72 होगा दिया। ऋषिकेश,
Sir, just explain this problem once again.
I said rate of hydrogen is 6 times the rate of hydrocarbon, right?
Yes, sir.
So if the rate of hydrogen is 6, then this will be 1, and rate is inversely proportional to the mass.
Yes, sir.
Mass of hydrogen we know is 2. So we kept the mass. Now we square both the sides. तो 6 का स्क्वायर 36 और स्क्वायर से ये स्क्वायर रूट हट जाएगा. So your mass will come out to be 72. अब
So this
72
formula
किसका
will
मास?
be
Same formula. Rate is inversely proportional to mass.
okay, sir.
For numericals, I told you this formula only.
Okay,
72
sir.
पे चेक कर लो कौन सा 72 बनेगा. This will become 72. Understood all of you?
Thank you, sir.
अभी इतना करते हैं, बाकी नेक्स्ट क्लास में करेंगे.
The